These are the examples to the performance tasks for questions 1, 2, and 3, part A. And so let's take a look at number 1, and it says that Ed earns $9.50 per hour working at his uncle's store. Jen earnings are listed below on this table. So the number of hours she works is 5 hours, and then she earns $47 for 9 hours worth of work. It's $84.60. 11 hours is $103.4, and 25 hours is $235. So what they want us to do is find out how much she earns per hour, because we need to find out who makes more. And so what we're going to end up doing is setting up a ratio. So they want to know the amount of money per hour. And so what we do know is we know that she earns, let's look at this one here, $47 for 5 hours. So what I'm going to end up doing is finding a unit rate. So a unit rate is when I go ahead and set up a division problem. I want to find out how many dollars in 1 hour she ends up earning. And so what I'm going to end up doing to find that out is I'm going to divide 5 into 47. And so right away I see 5 goes into 47 9 times, and I multiply, it gives me 2 left over. So I'm going to add the decimal point, bring the decimal point straight up into the quotient, bring the 0 down, and 5 goes into 20 evenly 4 times. So that decimal terminates, and so I can add a 0 as a placeholder to make the number a little bit more understandable. And basically what Jen has is earns, we'll say $9.40 every hour, or each hour. And so who earns more? Well, Ed earns more. Ed earns more. Now, how much? And let's see, because if I subtract $9.50, his earnings, actually subtracting $9.40 from Ed's earnings, that gives me 10 cents, 10 hundredths of a dollar, earns more. So Ed earns more, and we'll say he earns 10 cents per hour more. So that is number 1. And let's take a look at the next one. It says that members of the Hangtown Bowling Club pay yearly dues of $30. So this is an amount you're going to pay no matter what, and $9.50 to attend each. Okay, that key word there tells us we're dealing with the variable terms now. So attend each monthly competition. Okay, so we're going to write a function that describes this situation. So what we've got is an unknown of first our y value, which is money. This is the total amount spent. Total amount spent on bowling. And then we've got our x value. X value is time. Now I know it's time, and it's actually time in months, because the variable term with that keyword each tells us each monthly competition. So x is going to be the number of monthly competitions. So now I've got my variables defined. I'll go ahead and write my equation. So the equation is going to be y equals, and in the variable term, $9.50 per monthly meeting, or monthly competition. So it depends on how many competitions I end up going to. So I'm going to multiply the number of monthly competitions I go by 950, but then I have to add on that $30 that is like the constant amount, the amount that I'm going to have to pay no matter what. So now we're ready to solve a problem. It says, well, let's see, who is it? This is just a member attends 9 monthly competitions. So how much did he end up spending? And so that's what they want to find out. So we don't know how much he's going to spend, but we're going to find that out by taking the amount of competitions he goes to, 9 competitions, times by 950, and then add the $30. So we go ahead and multiply the 950 times 9, and that gives us $85.50. And then I'm going to take that number and I'm going to add on $30. That's going to give me my total amount. So I'll go ahead and add those two numbers. It makes $115.50. So this is the amount that that person will pay if they go to 9 meetings. So we can just say that in a sentence. We'll say the member would pay $115.50 to attend 9 monthly competitions. Alright, so the next one, new problem here, and this is just the first part of this. So it says Ned missed the bus after school and started walking home. The given set of ordered pairs represents the number of minutes since he left school and the distance in meters he was from school. And so they're asking, is this function a relation, or is this relation a function? And so when we're looking at functions, we're looking to see, do the input values have two ranges? So you see here he's a minute away from school. He was 20 meters. A minute from school, and he's walking for 1 minute. He's 20 meters from school. After 2 minutes, he's 60 meters from school. 3, 120, 5, 100, 8, 100, and 10, 200. So yes, the relation is a function, and the reason we would say that is because the relation is a function because each domain, or each input, has only one output. That's the definition of a function. So check out part 2 for the rest of the problems.